Hey YouTube, just wanted to show off a little project that I completed a little while back and have recently repaired so that it's in working order again. This is a high voltage DC power supply. That's the final output. This uses a Cockcroft Walton voltage multiplier that is inside this piece of Tupperware that I've sealed kind of sketchily and filled with mineral oil for insulation. Obviously, if looking at the spots, you should know that I'm not a professional in any way, but this is what is contained, or something like this is contained. I used 2CL77 diodes instead of these typical like microwave diodes. These can only handle about 12 kV. And 2CL77 handle about 20 kV. But a very similar setup in terms of layout and whatnot. So that's concealed inside of there. But basically, on the low voltage side, it has this power supply going from your wall line into to output a DC. I believe this is a switching power supply, and then that then goes to various switches to supply the other parts of this. In this case, this is just the adjustment for that power supply, so I can vary the output voltage that goes to the ZVS. And then the constant current supply is also varied. It can handle the varied output just like the ZVS can, as can the remote operated relay right here. So this is just some low voltage outputs that I included. Just kind of like a jankily made bolt with insulated bushings. Similarly for the constant current supply, I guess I can turn that on. All of these parts were ordered just from AliExpress. Super good website for cheap stuff. Not that it should be used for anything professional, but it's good for a purpose like this. I have this for another project idea that has come to fruition, just to kind of keep everything enclosed in one supply. So, like this says right here, this switch operates the ZVS. So basically that supplies this remote controlled relay that is controlled via this this remote right here. And also, sorry for the mess. I am certainly, as you can tell, just not a very organized person in general. Maybe that will change one day, probably not. Down there, so there's the ZVS driver, 0-volt switching driver. That's been kind of my point of failure. If I were to do this again, knowing what I know now at the end of this, or sort of at the end of this project, I'd like to keep improving upon this idea. But this is the amount of MOSFETs that I went through because that was my point of failure. These are not the cheapest part that I could have been replacing, so just a little bit of insight there. So that ZVS driver then supplies this high voltage, high frequency flyback transformer, and then that transformer's output goes to these terminals. I think that's the only thing different that I've done from other videos I've seen on YouTube. And this may have already been done and I just stole the idea and forgot where I stole it from, so I apologize if that's the case. But these are my high voltage, high frequency AC outputs directly from that transformer. So just like that, these are 20 kV terminals, 50 kV wire. My expected output on that transformer would actually fail before it hit a 20 kV output. Its limit is probably around 15 kV. And then it goes to the Cockcroft Walton voltage multiplier that is sealed inside of here. And then my supposed 100 kV-ish output is kind of my max. Goes through this 150 kV insulated cable. And I'm going to show off some of the arts that it can produce. So right now, as you can see, we're starting at 14.1 volts. So I'll show you the distance that arc produces. As you can see here, this is about we'll call that It's actually not touching, so it might be a little bit more, but about 20.8 millimeter distance or spark gap. And this is at 14.1 volts output from the DC power supply. So it jumps it relatively easy. Might be able to go a little bit more at that amount. Current supplied, I know you can't see it, but about a max of 4.6 volts, or 4.6 amps, excuse me. Also, if you ever make one of these things, or I don't recommend that you make one of these things, but just with any capacitor work, especially with high voltage capacitor work, make sure that you discharge. Yeah, here's what it looks like closed up. Just the antenna. So that's the box. Like I said, if anybody has any ideas for making the connection internally on that meter, be awesome. If you have any questions, please feel free to leave a comment. If you have any ideas of what to use this on or anything fun like that, please let me know. I have some ideas, but I'm always looking for more, and certainly would be nice to interact with the community a little bit. Alrighty, thank you.